The overall goal of this procedure is to investigate, using a novel 3D-Neuronavigation approach, the endogenous mu-opioid transmission in the brain during a spontaneous migraine headache attack in vivo. This is accomplished by first scanning a migraine patient in a typical headache and non-headache phase using positron emission tomography with the selective radio tracer carbon-11 carfentanil, which allows us to measure mu-opioid receptor availability in the brain. The second step is to verify co-registration and normalization accuracy by comparing the transformed MR and PET images to the MNI Atlas template in order to apply region of interest ROI analysis. The final step is to organize and store subject activation data in the Nifty data format to display the volume in a fully immersive, multi-screen clustered configuration. Ultimately, the 3D-Neuronavigation system allows for real-time exploration of the dataset and enables dynamic control and dissection of the neuroimaging data of the patient during a migraine attack in a virtual reality environment.
The main advantage of this technique over existing methods is that it permits the full interaction and navigation in real time through the brain of a patient during a migraine attack. This method can help answer key questions in the migraine field, such as which areas in the brain are more or less active during a migraine attack at molecular level in vivo, using carbon-11 carfentanil, a specific mu-opioid radiotracer, tapping into one of the main analgesic mechanisms in the brain.